In today's video I have one of these large LED displays, sort of thing they use in service stations to display the fuel price, and I think this one is out of that because I looked it up online. It's this Novyc, I don't know, NOVYC.com LED display. It's this EPC LDE, I think it's your model sign accessory, and it's all about service station lights on their website. Not much info on how you actually run these things, but it sounds like they're remotely run, possibly by radio. This one, I do have some older ones, red ones, which I'll get around to doing a video on one of these days, I guess. And they had, I think, like a computer network type connector which had the power and some sort of serial data or something, or clock and data. I sort of had a quick look at them and couldn't find a lot of info on what actually you need to feed the things. They got some sort of driver chips for the actual LEDs and then through various other things. So I don't hold a lot of hope of being able to actually get this thing to do anything. The other one, when you fire them up, they do have a bit of water damage, but you fire them up and I don't think anything lit up on them. So I don't hold a lot of hope for this one doing anything. I guess their probably default state is to have no display rather than 000, because someone will probably turn up at your servo and say you're selling it for nothing, so I want some for free. So they probably just blank themselves. Looks like it's got an out, PS1, in. So unless there's some sort of data line on this, that's got the same colours as the other one, but these may all just feed into each other. Not sure, I didn't see much info. There's very little online. Normally, unless you're a customer for these sort of people, they don't tell you a lot about them. But it looks like the power supply, it does say here somewhere, input 1, 36 volt DC. It doesn't have a PS2, even though it's labelled there. There's nothing connected, so it could have a 14 volt. So I want to try and find 36 volts at 1 amp. Plug that into there, see if it does anything. But yeah, there's some sort of, remote that you'd have at the counter at the service station, and possibly it actually uses wireless radio comms to tell it what to do. Which probably makes sense. You really don't only want to have power wiring out in your yard, I guess, for like the pumps and stuff, so you probably don't want specialised data cables and stuff if you can help it. We've got some sort of connector there. Oh, we've got dip switches. Looks like they're covered over with something, but yeah, there are dip switches there. At least this one doesn't look like it's been water damaged, but it doesn't mean it hasn't. You do wonder why they would have replaced it, but maybe there's a reason. There were actually 4 of them there, another one like this and 2 slightly bigger ones, I think they were. But I thought I'll just grab one and see if it does anything before I worry. They wanted a few dollars for it, so might as well see if we can get anything out of this thing. Ooh, something flashed. So I think the power hooked up alright. Oh, the little decimal point there. Sometimes it's not drawing any power. It's kind of what you'd expect. I guess I can check these other connectors, see if there's any voltages on them or anything. Almost looks like they've been daisy chained together, so I'm not sure what those other leads are supposed to do. If that's the case, we've got a black, a red, but they could be like a clock and data line, or who knows what they could be. Nothing from black to anything, not in DC. I'm not sure it would be data lines on that. I guess I could hook an oscilloscope up or something, see if anything happens. So that's in. If that's an in, there's probably not going to be anything coming out of the out, because we don't have an in. But so I don't even know. Suitable for dry or damp locations. Only the approved power supply must be installed, or you void your warranty. Outdoor sign must be installed with a NEMA 3 sign cabinet within a NEMA 3. Disconnect before servicing. Well, that would be normal. So that's about all we're probably going to get out of it. Something makes a noise, I think. All the segments are slightly flickering. Oh well, that's about what I expected. So they're possibly not a lot of use depending what chips are in them and whether you can do anything to play with the chips or anything and somehow feed them a signal, because I mean they'd be great for a scoreboard for sports or something like that, I guess, or a supersized clock. I would love to make a big clock out of one of these, it'd be pretty cool, but the problem is how much time do you waste trying to work out how to interface the thing to something. But in theory you should be able to, you think, feed something into the driver chips without too much hassle. Oh, that's all welded together. Oh, how does that work then? One of these must come off, I guess. Probably if I undo all these ones it should slide the other bit off, or does it slide out of the other bit? Who knows? Yeah, one bit looks like it's separate. Yeah, the bottom's separate, so I should be able to slide this off maybe. Like that. Might get through to three sides. Fucking hell, slightly tinted perspex. A few scratches on it, so it's not the best. Yeah, they look like all repeated modules. Are they infrared LEDs? What are those, I wonder? So maybe you can infrared remote control. It's actually got fans at each end. So I guess in the hot weather this would probably get pretty hot, and this, if it's sitting in full sunlight. And LEDs do use a surprising amount of power when there's a lot of them. But it does say it's only a 1 amp power supply, which I would have thought it'd probably draw more than that if with that many LEDs. I guess they've only got so many on at a time normally, but then I guess they've got to have maximum, have, you know, enough current to drive all of them. I mean, no one's ever going to have 8888, I don't think, but that gets rid of all the surrounding mess. Looks like these plug into some sort of, are they DB9 connectors or something? Kind of a cool thing. Anyway, I reckon these boards slide up and out, is my guess. They've got some sort of bus type setup. At least they'd be easy to repair, I would assume, if they're replaceable modules. Yeah, they're just a DB9 connector. Here we go, there's a bunch of stuff on the back. Soft revision. Test OK. So I've got some big driver transistors, or large-ish. Got this connector here, is not connected to anything. Dip switch. And then some sort of TLP 261-4s. And then we've got another, so it's copyright 2009, so it's not exactly brand new. Novik Electronics Incorporated, if that's how you say it. And we've got another chip with these unreadable, and someone's put a lacquer all over it. These unreadable laser etched sort of part numbers. I've got 2K450 in the middle. Something Dyne, is it? Or DNE? It's probably just a brand. I'll have to scrape that off, see if I can read what it is. So what would we have coming in, I wonder? Well, we can see all the tracks. I mean, you're mainly going to, it should be easy to find the power lines. If it's only got 9 connections, can't be that hard to work out, can it? Yeah, it's just a big, Well, I guess if we take the other end off, should be able to see what all the wiring's going to. But yeah, it would be cool to get a big panel like this up and running. I assume they'd be pretty high brightness LEDs. Maybe too bright for indoor use, but who knows. Oh, here we go, here's all the wiring. It's just basically the same module, 36 volt, made in Canada. So yeah, that's interesting. I wouldn't have thought they'd be made in Canada, but there you go. So I think that's the same. The two things that, yeah, God knows what that connector's for, maybe factory testing or something. Bunch of big diodes. The other one, oh yeah, it's got the same. And a couple of transistors, or well, that one's labelled U1, so it's probably a voltage reg or something. And then what's this black thing sticking? It's just a mounting device of some sort, or maybe to stop the plastic, the perspex pressing in or something. Oops. I almost have to take the whole strip board out to see, or of course, I wonder if a couple of them are for the fans or something. Looks like our in and outs are just joined together. Maybe they are just joined together, is that all they do? Oh well, in for a penny, in for a pound, I guess. Guess I better keep these in order just in case. So I'm probably not going to get anything out of them anyway. And if I can take this back plane thing off. I wonder if the fan's unplugged or are they soldered in? Probably soldered in, but I might be able to remove the fans with one screw anyway by the look of it. Don't know what's going on with this aluminium, a lot of scratch marks all over it. So someone's been cutting a heap of stuff on it or something, so maybe, yeah, maybe it was used for something before they folded it up. Ah, one more screw. Well, at least a couple of those might be connected to something. B plus, B minus, B plus 24, which we, unless it's got a copyright 2011 on that one, so that's a bit newer. Lead plus, lead minus, so that's, yeah, that's what our power supply, 36 volt power supply is, yep, PS1. So that at least gives power to each LED module, I guess. B plus 36, B minus, that goes to the fan. Yeah, some are made for 24 volts, so maybe that's like smaller LED panels or something. Would make sense, they'd make the one board for everything. Very hard with all this black muck on it to actually see the circuit board tracks, and half of them on the other side anyway. Okay, it seems some of these in and out things are connected to some of the digits but not the end two, so which one is the decimal point, one's the last digit or first digit. So I wonder if they keep them separate and kind of chain them. But you wouldn't think, how often would they wouldn't have the same prices showing. Maybe the $1, $2 thing or something. So I'm not sure what the idea is, but let's have a quick look again. The green one I think went to this second one. No, oh no, the green one went to this end one. Goes to the pin, I'm not sure, the end pin. Doesn't go to that diode, it looked like it does, but I think that was the only place that one went to. So that runs this, I'm not sure if it runs this last digit, but it goes to a particular pin on the last digit. Now any of these others loop together, doesn't look like it. So maybe the digit, if the panel is the same, it does something different. And this black one, I think, was the one. Yeah, it goes to the second pin, I think, on each of the first three, and then nothing. Does it go to any other pin? No. Doesn't go to the last two digits, or the decimal point in the other one. And the red, where did that go? That first one. Of the first three, oh, it goes to the last one as well. Yeah. Oh, so that one is common to all but the decimal point position, I think. Doesn't seem to be hooked to any fans or anything. So red is common to all but the decimal point. The other one's the first three and not on the last two. But if these are radio controlled, I don't see any radio receiver here, so I don't think... Oh, actually I think the radio, that's right, there's two pieces. One is the transmitter, and I think one is a receiver that goes in the cabinet with these and then feeds these. So that must be... So that radio control thing must feed these lines. That would make sense. So I wonder if it's like a multiplexing thing or a data thing. How does it address? Is each one of these set to a different address or something? Maybe that's what these dip switches are. Let's have a look. I bet they're all set the same. Although you set the end, the only one that you could access was that end one, wasn't it? Oh yeah, so that's 4 up, 2 down. That's all up. All up, all up. So maybe this is the one that sets the address for this particular panel. That would probably make sense. You set the dip switches, that's why I can get to them. For one panel or one unit, that sets the addresses for the whole thing. So this becomes like, say, panel 1, and then from the remote controller they send it via radio signal. When you tell panel 1, you can tell panel 1 what price to put up. That would make sense. And this is the problem with these things, is they're kind of useless unless you can... Well, I like this one because it's at least transistorized in these drivers. I should be able to work out how to fire up each set of segments, but are they, I guess the next thing is, are they multiplex? What do we, or have we got 1 pair, 2 pair, 3, 4, 5, 6, 7? Well, there you go. That would do our 7 segments. I'm not quite sure how they divide the segments, but it is basically a 7 segment display, so possibly switching each one of these pairs on will actually fire these things up. Bit hard to see which string of LEDs they're connected to. That's connected to that, connected to those two. And there's, what have we got? They're joined, I think. Then they go up here. Got a big line coming down. It's got to be the common of some sort. Don't know if they're common. Oh yeah, so the commons are those LEDs. I'm not seeing any coming from these other that goes into this chain, which goes through those LEDs. That just basically comes straight across, out. Oh, so is maybe each string of, maybe there's 2 transistors for 2 strings. Yeah, I'm gonna have to find out some data on these. That's why you could spend hours messing around. Find out the data, what these transistor pinouts are. I assume they are transistors. I can work it out with a multimeter somewhat, I guess. Got a bit of lacquer to weatherproof it, so probably aren't gonna be able to connect to anything much. That's gonna be the other hassle if you got a... Oh, so that's pin's just connected to that with a bit of scraping. Looks like you can, oh, so it's just a standard transistor, I think, so that's the base. Well, that's the collector, would you think would be the switchy bit, but that could be the voltage coming in. Where's our voltage coming in bit? Should be connected, if it is connected to a power rail. Alright, so that was probably connected to the LEDs. That would be the emitter then, surely. And that doesn't seem to be connected to a power rail anyway. But then we don't have to power. Oh, what am I doing? I'm not plugged in. Duh. Okay. You ain't going to be connected to the power rail if you haven't plugged the friggin' display board in. Oh, they don't want to plug in there. Oh, now you decide to work. That is the black, so they're ground. The collector, or maybe it's the emitter. Are they all like that? So the transistors, I'm guessing, are all what are they all though? Oh yeah, there we go. God, there's a bit of lacquer on some of these things. See that we're not shorting something out here. Don't think so. So that's that. I guess the other side is going to go. Where did I see that string of LEDs came back? It was this track. Where's it go? It was a common track. Yeah, it's this one here, which goes to there. And that's the positive. So that's your 36 volts maybe. Okay, I got this plugged in. I've only got about 31 volts this power supply on this bench puts out, so I'll run it off that for now. I'll just cut all the wiring off to get rid of that aluminium case. I had a bit of a look into what these chips were. You could only really read half of them on one of them, but turns out this little is a microprocessor, a MC908 KX2M Had a bunch of other numbers in between, but it's like a 68 HC08 sort of series chip. So it's got a little microprocessor, no surprises there. That does have like clock and data lines, I think, or data in and data out or something like that. Serial data lines, but I don't think we'll worry about trying to work out what that actually is fed by. But what I also found out is these other two chips here, as soon as I looked them up I knew what was probably going on, and they're both optocoupler chips. There's 4 in each package. So it's basically just 4 optocouplers, LEDs in on one side, transistors out on the other. As soon as I saw that I thought, well, that's going to be the interface between this microprocessor and these other driver transistors. Turns out they basically, you can see the lines on the inputs. The LED sides go all to this chip. There's 8 of them. Even though there's only, I think, 7 outputs used, because 7 segments. But it actually comes out, goes through these little bank of transistors here, 7 of them. Then it goes up through another little, like a pair of driver transistors, which I think are hooked in parallel anyway to the same line. And then you've got the 2 main LED switching transistors. So it should be as simple as just feeding, I might just pull it, there's a bunch of resistors here that feed the optocouplers from the microprocessor. So maybe if I pull them off the board and just fit similar resistors, because obviously these are LEDs, they need some sort of current limiting. And in theory you should be able to just hook up to like a 7-segment LED display into the LEDs to light, you know, basically light these up inside these packages, and the rest of the circuitry should then light up the big segments. So it should be as easy as that. What I don't know though is these are probably multiplexed, which actually would be useful, because if you want to run it off a clock chip or something, like just a clock radio type thing, easy enough to hook up the LED segments, But then you've got the problem of the multiplexing where it switches each of these displays one at a time very quickly. So it lights up sort of one segment at a time, or one segment in one display, then switches to the next display, lights up a different one, and keeps sort of cycling through. Or maybe it does multiple ones at the same time, but it has the segments for each display individually, sort of thing. I'm not sure if they do multiple lines. I assume they would. If you need, like, say a 2 or something, you need 1, 2, 3, 4, 5 segments, maybe all 5 of them lit, but only on this display, and then a different set of segments on the next one. So that's basically how, so it's like a data line, and then it's set for each display and they sequentially switch them. But I would assume these probably have the option to do that, because chances are they would have been multiplexed anyway. I think I have seen camera footage of these service station signs, and you can see them sort of flicking in like dash cams and those sort of things. So I'd say they're multiplex, so that will be another thing to possibly find out, if there's a separate transistor or something here that switches the multiplexing. The other thing I want to check out, there's a little voltage regulator here. And the other thing, what did I find out? I think there's actually an NE, oh, that was on the decimal point board. I can't really read it that well, but it's a triple, it looks like a NE, is it an NE or a TL 555, I think it was. Yeah, TL 555, and then it's got something on the end. I tried 5550, that didn't come up as anything. 555D or 555Q. It's got some sort of digit on the end, but very hard to read with all this lacquer all over it. But that's not particularly important. If I do make this in a clock, all I want is 2 fixed sets of LEDs like that. Maybe I can pinch some off one of the displays or something. If they're not used like on the one segment, I could just get another 4 and put them, make a new board with 2 squares of 4 or something. But I'm a long way from doing that, but it looks like this is relatively simple. I do want to check this voltage regulator to see if it's currently hooked up when I've got like the 36 volt rail in there. I think it's common in on the tab, it's just like a 7805 type regulator, I think. And you've got to be careful whether you're actually making a connection here. My guess is possibly that the microprocessor isn't even fired up. I don't know if this said, what did I have it written down as a GNKF50 or GK14E, I forget which one. I did look it up and found that it was a voltage regulator. Those ones are TLP 281-4. There's a TLP 281, I think it's just a single optocoupler. They're a -4, so 4 optocouplers in one package. And I think that was the main chips on this board. That's all there really is, but doesn't look like we've got any voltage to this thing. Guess I can double check across that cap there, which would most likely be its output. So I'm assuming one of these other lines should be powered up, and more than likely, see, I don't know if we fire up the microprocessor, if it'll do something. What does that cap say? 10. So because it's a 10 microfarad, I can't really see a voltage. It'd be nice to know what voltage is, because it always gives you an indication of what the line might be. Possibly it's an 18, so I doubt that's a voltage. 10 GHAY18, so that doesn't tell me anything. It's the only electro on here. And I didn't look at what these diodes are doing, but I did trace the circuitry through this just to make sure that these chips did go through, and they did. It's quite hard to find because it's plated through holes and all this black stuff. Really, it wants one of these boards stripping down so you can see where all the tracks are and then draw out a full circuit. But I thought, once I saw those optocouplers, I thought, well, that's going to be the interface between the useless microprocessor bit and the useful bit of driving the LEDs. And that all looks correct. What this stuff does, there's another Q2 here, which I guess I should check. But I would assume, I don't think I actually checked it, but I'm on that pin. I guess I should do a continuity check, because I would assume, not so easy now, I've cut all the wires off. And then again, it's not too bad. I would assume some of this, I think we checked it for ground. Yeah, it's not even connected to ground, that's weird. Check the green wire, nothing. If that is meant to be the ground pin, I would have expected it to be connected up to something. Okay, so that's the red wire. So I think we can say that's the input some sort of lower voltage goes in there. So I wonder if that is, let's have a look at this again. There's no PS2, but we've got in and out. It did say there was another 14 volt. 2 should be 14 volt DC. Wouldn't be surprised if something like 14 volts is meant to go into that. Would make sense if it's either a 12 or 5 volt regulator. Probably 5 volt would be my guess. Let's see if that cap's on the output of it. Yeah, sure enough. And that probably, I don't know if it can connect very well to this microprocessor, but more than likely goes, I forgot, I should have got the pin out. Which pin, maybe the end one, or one of the end ones, which pin is the voltage, but it doesn't seem to go to any of them. Assuming we're breaking through the lacquer. But I have had not the best luck getting through this lacquer. You often measure things and they're not there, then they are there. Interesting. Let's just check these pins. Nothing. Am I still connected though? Oh, see, now there is something. So that pin there is connected to a positive, assuming it's positive. Unfortunately, I cannot trace these tracks very well. It'd have to go to that chip, I would think. Ooh, that's something just... There's 1.5, so it must be making some connections. I might have to look up the data sheet again and see which pin is the B plus for that chip. Does it connect to anything else weird here? Seemingly not. Now I think, well, these diodes, I think they're connected, I thought they were connected to the red actually. Nope. No, no, nothing. Oh, black. That's what I mean about you make a connection, then you don't make a connection. Now, assuming these diodes go through that way, and again, we're not. Yeah, so that must be some other voltage, that black wire, I'm guessing. Though what it runs, are they all in parallel? Nope. I think they're all in parallel. So we've got 3 diodes. Why would we have 3 diodes? So that's protected by a diode, I guess. Reverse polarity protected, probably in case someone installs it wrong, I guess. We've got 3 of them in parallel. They all go somewhere. To one side of that resistor. Is that a resistor? Yeah. I'd assume one of them goes to this transistor, but it doesn't. Barely connect to that one. Oh, wait, we've got to go to the other pin too. All pins, I guess I need to check. Ah, there we go. So that end one goes to this transistor. I would assume that's some sort of regulator, so maybe if I put around 14 volts, this is where it gets a bit risky. I guess the other thing is, what pin are these? These have got a B plus line as well. So it's really a matter of, unless there's another lower voltage regulator somewhere, or maybe a voltage regulator that is not 5 volt. I wish they just have a standard, I think it just said generic voltage regulators. It could be the other ones, the 5 volt or 3 volt or whatever they use. But I don't know which pin of this chip it would be, or this transistor. Ooh. Very low, but not fully connected. And it could be going through a resistor or something. Oh no, actually these are just, they don't have separate. No, they're not like an normal IC. What am I thinking? They're just LEDs and transistors like I said before. So that doesn't help. So if that could be a Zener diode or something that sets that to a certain voltage. That's the black wire, we've got the red wire. So do I risk hooking more? But the green I think went to some of the other connectors, but it doesn't go to ground. Well, something must be ground around here surely. Well, that won't be. That should be ground. I'm pretty sure that regulator is, they're not grounded. Oh, that'll be the indicator, won't it? Yep, that's ground. That must be connected to our ground. Oh, so is the ground via a diode or something? Hang on. That's not ground. Ooh, what? Okay, that complicates things. It's just the black wire, is it? Ah. So that's possibly completely separate from the LEDs. So those diodes are all connected to ground. That's why it threw me, because I'm an idiot. I didn't realise. Oh, that is too. What? So they're not diodes. Well, they say they're diodes. I was going to say they're capacitors. But hang on, wasn't that connected to the red? Nope. That is though. So as the voltage comes into this, so the black and red here are, I'd say, a separate power supply. On this, they were the ones on those 3 terminal in and out connectors. Green I think we can forget, so maybe if we put 14 volts in there. So I was thinking this was connected to, I forgot now. Not connected to there. That's the red wire in. So maybe these diodes are reverse current protection, but not by blocking something. They're there to short out the ground or whatever. Maybe they're even like the CB radios. They're a big Zener diode that both conducts if the voltage is too high, and if you get reverse polarity, you'll get voltage flow and blow a fuse basically, and same if the Zener diode conducts. So that could be what that is. So I think I'm going to have to risk hooking up about 14 volts as well into this and see if that gets our microprocessor running. It probably won't do anything even if I do, but let's hook our main voltage up. Ground up to there. I better have a look at it. See if any smoke comes out and see if anything lights up at all. Whoa, dude. Oh, we've got a test mode. How cool. Ha! Well, there you go. That's pretty wicked. Oh, I'm starting to like this display. It's a bit... Oh no, it's stopped doing it now. Was that a test mode? Possibly. Yeah, it looks like a segment test. That's brilliant, isn't it? And then it just got a 7 or whatever going there. Probably a little bit dimmer. Well, they've dimmed them down anyway compared to what they were, I think. But we've only got 30.5 volts beating the main B+, but oh, that's cool. So that probably just, maybe that's something that it does. It goes through the display when they fire up in the morning or whatever, when they apply power. And then it just sits there with like a dud if it doesn't get any other data. Just these little semi-segments, not sure what they're meant to represent, but oh, excellent. So in theory, if I plug more of them in, we should be able to test all of them. Although, well, I guess I shouldn't really plug it in. I've still got the other voltage on there, haven't I? Naughty, naughty, but I don't think it'll worry anything too much. There we go. Oh, brilliant. Well, at least I know I can test the things. A bit flickery, but that's probably just part of the test mode. So these are probably good working displays by the look of it. I was half expecting something to be wrong with them, which is always a risk to buy these things. Oh yeah, that flicked because I left the power on, but that's okay, I think. Yeah, seems to work. I guess this time I'll actually disconnect the... I guess we could put the... Well, we don't really care about the decimal point. We know that lit up anyway, so... And I'll try one more. You can see them quickly flick up anyway. But nice to get a proper... Nice. So like I say, I don't know what you can feed these microprocessors, but I don't think I overly care. Probably the only thing I need to work out is, does it have multiplexing? Because even if it doesn't, I guess you could come up with a way of switching each panel with some sort of transistor or something to the common, I guess. I assume they've got some sort of common. We don't know for sure yet, but that's a pretty good bit of progress. Good idea that they put a test mode in there, so that's a brilliant thing. You can, once you know what to hook up. So I was putting only 12 volts into the red and black on that in and out, and 30 odd volts into the other two, which I meant it says on the back should be 36, the PS1 or whatever connector it was. Yeah, PS1. Yeah, nice and bright, because I'd actually just like think it'd be cool to hook them up to just a clock radio. Hook into the LED segments off that. But I'm just trying to think, if they're multiplex, we've actually got to hook all these opto couplers, I guess, in series or parallel or whatever. Although, let me think, if we've got individual segment, because yeah, in the clock radio display they're actually going to be connected in lines, all the A segments join together, all the B segments and so on. So you just need a way, even just a transistor, you could hook all the A segments in series, 4 LEDs in series, one transistor to switch them straight off. I was hoping to actually hook the LEDs straight into this, but it's not going to be quite that simple, I don't think. Though, if it's a multiplexing display, it should be able to handle a few more in parallel or something. I'm not sure, I'll have to have a look at the circuitry again, how they do it. But I think they're higher current thinking, because they've got to do multiple displays at once. So it might be fine to hook them in parallel or something. Anyway, we'll have a look. Parallel, series, whatever, I can switch it with something. And then it's just a matter of finding whether there's a way of switching... I didn't even check what voltage that was. A way of switching the entire set of segments, the whole display piece like this, the 7 segment. So you need 4 switches to switch them sequentially. And if you can manage to synchronize all that in the right order, you should have a working unit. And is that, I wonder if that is an infrared, is it a photodiode, an infrared LED? I assume it'd be more for picking up, or does it just pick up light level? Oh, it could be just a light level sensor, I guess. These things you would assume would have some sort of auto dimming, maybe, because these would be pretty bright at night. You'd actually want them to dim down at night, so maybe that's just a photodiode to pick up the ambient lighting levels. I mean, one to do all of them would be enough, but I guess doesn't have to have one in each. It's not like they cost that much these days. Oh well, that's good. So we made a little bit of progress. I know the segments work. It's definitely got potential, this one. And whatever, look, I do have an old... I've got 4 red ones. They only cost me $5 each, but they do have water damage. But from memory, they looked like the chips driving were a lot more complicated. But I might have to dig them out again, just in case that's got a similar opto coupler setup or something. But I don't think they did, but I can't remember how far I got. But I put 3 of them away, out of mind, out of sight for a rainy day, but there is still one in the garage here, so I might pull that out and have a look. And yeah, if I can sort of, now that I know that these may be used for, I might even grab one of the bigger ones or maybe just buy the lot of them and hope I can do something with them. That's got some black stuff on it, no idea what that is. Because these would be pretty cool if you could make a clock, or I don't know what else you could really display numerically that would be very interesting, but they would make a really cool, just a clock. Super big one, super bright one. But we'll see what I can do, and yeah, I'll have a little bit more of a play working out some more of this circuitry, I think.